name is Maribel, and for today I will be solving problem 2 from our ECEN 350 final exam. Alright, let's get started. Hillary, a student in ECEN 350, wants to execute the following instruction in the single cycle data path. This one marked below. The single cycle data path below shows the execution of this instruction. Several data path values are filled in already. We must provide for the remaining 10 signals in the diagram, which are marked with the question mark symbol. We're asked to show decimal values. Assume register 29 contains the value 128. Assume register 8 initially contains number 1996, and that PC initially has a value of 12,004. If we cannot determine any of these values, we must mark it as X. Alright, first things first, load word is written as first the value stored in register RT, followed by the immediate offset value, and then the value stored in register RS. This will help us solve for the values in our data path. Alright, first things first. Let's start with this area after the instruction memory. For read register 1, I marked it already as RS. We know from inspection that this value is just 29. Alright. Right below it, we know that RT is also 8, right? Just from inspection. Okay, let's mark that. Alright. Below is our immediate value. The number in our instruction that isn't a register value is our immediate value. In this case, we do this because load word and store word are technically I-type instructions. We can determine this through our MIPS green sheet right here, load word, I-type. Alright? So, again, just from inspection, we know our value here is just 24. Alright? Now, because we are writing our register value, we must take this frag right and set it equal to 1. Alright. Next, this value here is the value stored in our register RS. Now, from our given instructions, we know register 29 contains the number 128. Now it's just not register 29. Now, because of the money sign, we know it's the value stored in register RS. So we will mark it as 128. Alright. Next, we're at our ALU. I want to ask you guys, on what two numbers is ALU operating on, and what is it doing with them? ALU clearly is operating on the value 128 and our immediate value 24 down here. And it's clearly adding both of them. So, for our ALU result right here, we add 128 and 24. We simply get 152. Took a little look at my calculator there. Alright. Next, we're in our data memory. In this case, we know our memWrite is 0 because it's not writing anything to our data memory. So let's go ahead and fill that out. 0. All right. Now, on the other hand, memread is 1 because we're reading a value in data memory and writing it to a register. From that explanation, we get memread as 1, but we also get mem to reg as 1, even though it didn't ask for it. Since we don't know the exact value, because it's just whatever is stored at the offsetted address, then we know this line going into, right here, going into our write data, we know this line will just be an X, since we don't know the exact random value. Alright, now, only box left to fill out now is this one up here. This whole top part is just the program counter. Because we were given that the program counter right here initially has a value of 12,004, then for every instruction, we increment our PC by 4, with the exception of our branch and jump instructions. So because this is a load word instruction, we add 4 to our 12,004, and we're left with 12,008. Simple as that.